I'm very sorry, just a few seconds. Just a few seconds and I will rename myself.
Okay, thank you.
Yeah, colleagues, let's wait a few more minutes and start.
Доброго денька. Добрий день.
Доброго дня.
Morning.
Пару хвилин чекаємо і будемо починати.
Well,
Hello.
Вітаю всіх. Окей.
Доброго дня.
Добрий день.
так. Дуже Олексійович, дуже радий вас бачити.
Взаємно. Олександр.
Олександр, так.
Вітаю, вітаю. О, так вже видно, а то було трошки темні, цей засліплено. Угу.
Так.
Вітання організаторам. Таку потужну конференцію змогли організувати. Це приємно.
Дякуємо, Анатолій Олексійович.
Угу. Це приємно. Ще хтось нас підходить, Тетяна, так?
Так, ще пару хвилин буквально, може ще
Угу.
хтось приєднається до нас.
Ясно. Хмельницький на піку коронавірусу.
На жаль.
Ну,
Так усі.
да,
І Одеса на піку, і Чернівці знову, так.
та, і Львів не відстає.
Львів не відстає, так.
Ну, я родом з Хмельницької області, то мені приходять повідомлення стабільно, бо вона там слідкує. І от там Шепетівка, Славута, Хмельницький там, і так далі. Ну нічого, треба трошки потерпіти, я думаю, що скоро воно все піде на спад.
Так. Сподіваємось, так.
Ну так. Ну то видно по тих країнах, які провели вакцинацію, то там уже різко впало.
То ми ж не знаємо, до чого воно призведе у наступних поколіннях.
Є таке питання. Ну, залежить, яка вакцина. Там же ж є, можна почитати склад, і можна собі прийти до висновку, яка може вплинути, а яка не може вплинути.
Ой, знати джерела усього цього починаючи з самого вірусу, звідкиля він.
Ні, ну то це ж можна догадатися, які тут проблеми. Тож вам
Ми
офіційно.
комусь показалися зайвими на цьому світі. Якщо там 20 людей має те, що мають 3,5 мільярди, то вони, мабуть, вирішили, що вони нас забезпечують усім. Навіщо ми їм?
Да.
Отаке враження.
Ну, можна так догадуватись, можна інакше догадуватись. Це
Сподіваємось на краще.
ля-ля, це не серйозно.
Dear colleagues, let's start. I am Tatiana Govorushenko, General Chair of the second International Workshop on Intelligent Information Technologies and Information Security Systems, IntelITSIS 2021. Thank you all for participating in our workshop, for your interesting papers. I am glad to welcome all of you to our workshop, but unfortunately online, not within the walls of our Khmelnytskyi National University. Our workshop is organized by Computer Engineering and System Programming Department of Khmelnytskyi National University with the support of the public organization Ukrainian Scientific and Educational IT Society. IntelITSIS 2021 focuses on all technical and practical aspects of the latest research and results of international scientists, practitioners related to intelligent information technologies, to information security systems. This workshop provides opportunities to exchange new ideas, to establish business research relations, and to find global partners for future collaboration. I hope that the workshop results make a significant contribution to the development of intelligent information technologies, information security systems in Ukraine and in the world. The program of our workshop includes a plenary session today from 2 till 5 p.m., two sections, section first, intelligent information technologies, and section second, systems of information security, which will take place tomorrow and the day after tomorrow according to program, as well as awards and close ceremony, which will take place on Friday, March 26th from 4 p.m. I invite everyone to attend all the events of our workshop. I wish everyone fruitful work and interesting presentations. Welcome. Next speaker who will say greetings words is Professor Oleg Senyuk, Vice-Rector of Khmelnytskyi National University. Welcome, Oleg Mykolaievich.
Thank you. Good day, dear conference participants, dear organizers and co-organizers of the second International Workshop on Intelligent Information Technologies and System of Information Security. It is a great joy to greet you all. I am very pleased that I have to speak at conferences of such a world level. Publication of conferences materials in Scopus and Web of Science is world level. The results of scientific and technical activities should have practical value and scientific novelty. They should be placed in well-known international publications and put into production. Our university has powerful research and production laboratories as well research centers of various profiles. Basic and applied research in many priority areas of science and technology are performed in our university. I believe that the priority area for the development of science in our university as increase in the volume of service and developments under business agreements and international grants. There are still enough science in Ukraine who have significant and knowledge and skill, practical experience, and can critically think and evaluate any process. The main task of our country and university is to create the conditions for the transformations of the potential in the driving force in the growth of the production and economy in Ukraine and the well-being of each of us. The opportunity to publish the results of our research at conferences of the same level will allow us enter the world scientific space. I wish the participants to see many interesting presentations or to participate in constructive discussions and to discover something new. Thank you.
Thank you, Oleg Mykolaievich. Next welcome speech will say by Dr. Science Sergei Lysenko, Khmelnytskyi National University, Ukraine, International Program Committee co-chair. Welcome, Sergei.
Thank you, Tatiana. Good evening, dear colleagues. I'm very happy to see all of you. And as an International Program Committee Chair, I'd like to thank you. Greetings to all of you today. I'm very happy to see you on the second National Workshop on Intelligent Information Technologies and Systems of Information Security, IntelITSIS 2021. I'd like to ask you thanks to all authors, reviewers, and colleagues for their work. Concerning the topics of our workshops, I'd like to say that IT industry is quite attractive from different sides. For those who choose IT as a scientific field or as professional, IT is one of the most dynamically developing sectors of the economy in the world. The situation is not surprising because IT is a fairly promising area. Those fruits greatly simplify people's life, especially in previous unpredictable 2020. From other hand, cybersecurity is also very important today. Cyber attacks are currently prevailing in all networks, user network devices, and environments and applications. There are more complex these attacks, the malicious in the distributed and mobile environment, and new threats emerging every day, and they are even more stealthy and intelligent and targeting the vulnerabilities of operating systems, browsers, and applications. Moreover, new network protocols and applications open new possibilities to attackers. That's why there are a lot of new challenges, and we as researchers and developers are to respond to them. So let us discuss new ideas, approaches, techniques, and intelligent information technologies to make this world more simpler and more secure. Let's start our workshop and let it be interesting and fruitful. You're welcome.
Now we will have the following presentation about IntelITSIS 2021 trends. I am a speaker and now I will share my presentation. Do you see my presentation?
Yes.
Yes. Thank you. Second International Workshop on Intelligent Information Technologies and Systems of Information Security, IntelITSIS 2021, is organized by Computer Engineering and System Programming Department of Khmelnytskyi National University with the support of the public organization Ukrainian Scientific and Educational IT Society. The IntelITSIS 2021 was originally planned to have a physical location, Khmelnytskyi, Kamenetska Street, 112, building number 1 of Khmelnytskyi, National University, but the physical meeting was cancelled by authorities of Ukraine due to coronavirus, COVID-19. So unfortunately, now this event is conducted remotely in video conferencing format using the Zoom platform. For the second year in a row, we have a situation where we can't meet live, but have to use only online communication. But we have to be prudent, to be aware, to be careful. So we have to accept this situation as it is. I think that humanity will soon overcome this pandemic, and next year we will definitely meet live in Khmelnytsky, a picturesque city on the book, and at our native Khmelnytsky National University. General chairs of the second international workshop on intelligent information technologies and systems of information security are me, Professor Tetiana Govorushenko, Khmelnytsky National University, and Professor Oleg Savenko, Khmelnytsky National University. Chairs of the International Program Committee are Doctor of Engineering Sciences Sergei Lysenko, Khmelnytsky National University, and Dr. Peter Popov, City University of London, United Kingdom. Organizing committee chairs are Professor Alexander Barmak, Khmelnytsky National University, and Dr. Elizaveta Gnachuk, Khmelnytsky National University. International Program Committee has 39 members. 100% of the IntelITSIS 2021 International Program Committee members have more than 10 DBLP papers. There are the representatives of 10 Ukrainian universities and of 16 universities from around the world: United Kingdom, USA, Austria, Slovakia, Czech Republic, Turkey, Egypt, Poland, Estonia, and Greece. Second International Workshop on Intelligent Information Technologies and Systems of Information Security received 135 submissions from Ukraine and the world. All papers were evaluated by 2 or 3 reviewers. Based on the reviews, a rating of papers was compiled. Papers with a positive average scores were accepted for presentation at workshop. According to the decision of the International Program Committee, 59 papers were conditionally accepted for presentation at the workshop. We received camera-ready papers, which were also evaluated by reviewers. It was checked whether all comments, recommendations were taken into account by authors. As a result, only 58 camera-ready papers are accepted for presentation at the workshop. The IntelITSIS 2021 joint scientists from Ukraine, United Kingdom, USA, Austria, Slovak Republic, Czech Republic, Turkey, Poland, Kazakhstan, Estonia, Germany, Egypt, Algeria, Malaysia, Morocco, and Greece. In general, the representatives from 29 universities from around the world, 1 industrial partner from Ukraine, and 45 Ukrainian universities will take part in the workshop. On the slide, you can see lists of Ukrainian universities, the representatives of which will take part in workshop. On this slide, you can see list of universities from around the world, the representatives of which will take part in our workshop. So final acceptance rate is 43%. I wish everyone fruitful work and interesting presentations. Welcome. Now we will have plenary session. Our first plenary presentation is Health Supervisor, mobile application for round-the-clock remote monitoring of the human functional state by Professor Anatoly Melnik, the John Paul II Catholic University of Lublin, Poland, Intron Ltd, Ukraine, and Yuri Morozov, Bogdan Gavano, and Petro Gupalo, Intron Ltd, Ukraine. Anatoly Alexeyevich, welcome.
Thank you, Tatiana. Do you see my screen?
Yes.
Yes, good. Ladies and gentlemen, I want to present for your attention this our report. No, first, I want to thank for organizer of this conference for the possibility to take part, and of course for the possibility to make this report. We present three companies: Intron Ltd, Lviv, Ukraine, Department of Artificial Intelligence in Catholic University in Poland, in Lublin, Lviv Polytechnic National University. But mainly we present this project. It was executed some weeks ago, project as startup, and you can find the result of this project, about which I will say you on this page. See here. At first agenda of my report, I will say you shortly about Intron company, with which we executed this project. The goal of study, field of using of this project, our project, why remote monitoring, state of the art, our elements of monitoring system, structure of this system, how we select pulse oximeters, organization of remote monitoring, and some time I will spend to present for you how information is processed in our application. After this, I will show you main features of this project and future work. First, some words about Intron company. As I think you will find more information about Lviv Polytechnic National University and Catholic University Lublin, but maybe someone from you want to know about Intron company. It was founded in 2000 year. You see here web page. Main research fields is high performance processors with parallel architecture, set of processor for information security. We execute large quantity of project in this field, set of IP core generators, for example, fast Fourier transform, Hartley transform, cosine transform, multiple memory, and many other. Our achievement, we create fastly identity in the world, such C2 hardware design language tools for automatic high-level synthesis of specialized processors. The system is working today. Next, we create such new direction self-configurable FPGA-based computer systems. You can find this on separate page. Next generation autonomous intelligence system, multi-agent system. Next direction, hardware and software platform for cyber physical systems and Internet of Things. And last one, about which I will say you, remote monitoring of the human functional state. Here on this slide, I present some of our project which were performed during last year. Self-configurable FPGA-based system. This project was executed in the international cost project, so named NESUS. Next one, dynamic parallelizing system for shared memory processors. It was executed in cooperation with University of Applied Science in Nuremberg, Germany. The algorithm processor for fast orthogonal transformations, in cooperation with this university. Reconstruction of 3D objects from raster altimeter data. It was performed on the order of Jena Optronic, Germany. Non-destructive testing software system for X-ray 3D computer tomography. This project was executed for TECH Institute, Central Institute in Korea. Next one, computer system for Earth surface exploration for spacecraft SIEGE-2, National Space Agency of Ukraine. And last one, project mobile application for patient with COVID-19. Now, this project that I will present is the next step after this project. Where the place of our project. On this slide, you can see some directions in telemedicine. And between them is remote patient monitoring and mobile health. These two fields, this project belongs to these two fields. More precisely, here I have found in internet this global remote monitoring market represented by iMark company, and by red marks, by red signs, we iMark fields or elements of this market which belong this our project. You can read for application for cardiovascular disease treatment and monitoring, at first monitoring, of course, weight management and fitness monitoring. By region, we have created this project for all world. By device, you have seen pulse oximeters and use hospitals and clinics, home care settings, and other. Now, the goal of study. When we start this project, we think that there are, we start from these main ideas. Human functional state should be monitored by a professional or people whom you trust. Next one, that people, the human must be monitoring around the clock and remotely. Consider as first, before this project we have executed project for COVID-19. We think that we select for testing next following parameters: blood oxygen saturation, heart rate, and respiratory rate. Application smartphone oriented, and application should be based on very less device available on the market. It's very important. Is not implemented by our team. You can buy these devices at the market. Here I show you fields where can be used this application. It's clinical practice and epidemiological study of clients with COVID-19, oncology, vascular, pulmonology, and heart diseases, and other. Monitor functional state of the elderly people very important, athletes, children, etc., and so on. Protection of people with dangerous professions. Here, this slide describes why remote monitoring. I think you understand this question, but maybe shortly. Risk of infection, a lot of people in hospital, and simultaneous control of many clients, possibility to control clients at the home, and possibility to control, for example, patients when they leave hospital, and all these problems, our remote monitoring system is solved. What were before this project? Last design, it's presented on this paper, was executed in England, some medical university and technical companies create such system that used to similarly to our project, smartphone and pulse oximeters, but they do it. They create such centrum and they control patients only using SMS messages, not round the clock monitoring. Now, some words about around the clock monitoring method, which we implemented in our system. As you see, participant of this system are supervisors, can be many supervisors, clients can be many clients. Every supervisor forms a group of clients. The role of supervisor can be, for example, doctor, coach, relatives, and so on. In the role of clients can be any people. So supervisor forms own group and can control remotely their health, and another supervisor too, and so on. There are three main elements of our monitoring system: a sensor network of wireless pulse oximeters and Lincoln smartphones. On these smartphones are installed our mobile application. Next element of our system is server software, which collects real-time blood oxygen levels, pulse frequency, and respiratory rate 22 hours a day from monitoring and critically ill clients, including the protection of personal data. Next, health supervisor mobile application of supervisor monitor functional state of clients and to warn supervisor of dangerously low oxygenation level. As example, I think you know that at the market there are a lot of devices which can measure parameters which I pointed previously. Or I said oxygenation level, heart rate, and so on. Here you can see example how it's present in your smartphone when you have a smartwatch or another devices. But we go further and we create this application which allow send information from this very less wearable device through your smartphone, through user smartphone to computer network, to the internet, and to the data centrum or server. Its main idea to transmit data from wireless device through smartphone to the network, to the server, process this data in the server, and present this data again through internet for a supervisor for his smartphone. We start this project. We analyzed a lot of devices which can measure parameter about which I said. We made the criteria of comparison and selection of pulse oximeter were following: size, portability, size and weight, wireless communication function with the smartphone, ability to export blood oxygen saturation data on Google Fit. I want to extend this, on Android and Apple Health on iOS. Measurement accuracy, duration of autonomous walk, periodic measurement. Here in this table, you can see characteristics of some pulse oximeters which we consider during our project to select most suitable for this function. You see here Biomed pulse oximeter by Beurer, Xiaomi, Huawei company, Honor Band, and so on. Garmin, I want to say that Garmin company a lot of help for us to they give all needed information, and as we see at the finish that very good devices they product, and they are very suitable for this function that we use. And of course Apple Watch we consider it too. The result of this study was the following. We, from the point of view of easy of use, fitness bracelets are the best because they do not interfere with daily human activities. In terms of frequency of measurement, the best are smart watches and pulse oximeter on finger. I said about this. Beurer. Next one, in terms of autonomy, bracelets and watches are the best. In terms of measurement accuracy, all tested oximeters are approximately equal. And smartphones are the leaders in the terms of compatibility with services. Therefore, according to set of criteria for continuous monitoring of clean functional state, the smartwatches best. I said this. The next slide is about organization of remote monitoring using our health supervisor mobile application. So at first you have to buy mobile device with pulse oximeter functions, and this device has to have remote have wireless connection to one of mobile smartphones which have to be compatible with Google Fit on Android or Apple Health on iOS. After this, client connects his bracelet and mobile application using Bluetooth technology. After this, that he installed our mobile application on his smartphone. Next one, application must be registered on the server through the setting of the application itself. Next step, health supervisor mobile application starts transmitting client parameters to the server for storage and processing. Next step, health supervisor application at the supervisor smartphone registers with the server and access client data. So I said people who take part in this process, client and supervisor. Application has to be installed on the smartphone of client and on smartphone of supervisor. And after this, supervisor can see remotely see work of client organism. No, it's his parameters, his health parameters. Now I want to present you client data in the supervisor application. At first, in supervisor group, in this case, in this example, you see two clients. Every one of them, for example, this John Smith, here is presented its these three parameters: oxygenation level, heart rate, and respiration rate. When you press, you will see. No, of course, client to have one or more supervisor. Here you see three supervisors in one client. When a supervisor press on this button, he will see following information. For example, concerning a level of oxygenation. Level of oxygenation, you will see level of he will see a level of oxygenation during one day, during week, and during month. And when we press here, you will for day you will see for this example you see level of oxygenation of our client during week. You see between 90 and 100. Next, you can see it in more detail on this graphic, or you can see this in more detail on the table. For example, in 7 o'clock, level of oxygenation was 92, and for example, in 6:57, level of oxygenation was 93. And if you like, you can see all day or all week or even all month. The same can be considered level heart rate and another parameters, respiration level. Next, we create some special tools which allow to see to install critical indicators warning. Here you see limits For example, you install from 90 to 100. When this level will, when the data will out of this level, then a supervisor will receive a signal to make attention on this client. The same you see limits for level of oxygen, heart rate, and respiration, as you see on this picture. Similarly, you can install such a range for these parameters in different day and different time. For example, from 10 to 30, 1330, and so on. Main features and benefits of using the Health Supervisor mobile application. At first, assignment of clients to supervisor. Next one, automatic collection of data on the client functional state without their participation, and transmission of this data via the internet to the server, remote monitoring of pointed parameters, ability to add control functions for other health parameters, accumulation of control result and achieving data history for each clients, monitoring 22 hours a day without contacts between the client and the supervisor, presence of function of warning, I said about it, possibility to set individual limits per each client by supervisor, and ensuring the possibility of self-monitoring by clients of their functional state. We make such investigation. We create special group to which made investigation and said that all data that are transmitted from from wireless devices and data that are displayed as the screen of the supervisor are the same, that are not modified in our system. For this, we use following wireless devices: Garmin, Vivo Active 4, Bayer, Huawei, and we receive information that there are no changing of information in our system. It's very important, of course. Technology that used for the project implementation you can see on this slide: in server, the database, and mobile application. To use this technology to design this application. Future work. No, of course, we consider many ways to improve and to develop our application. Maybe in shortly, at first we want to include the possibility to process data using artificial intelligence technologies to improve protection of data and to give more possibilities as for clients and as for supervisor. We present developed application for some medical structure. First, I want to point these 4 members of the anti-crisis headquarters for combating the spread of acute respiratory disease COVID-19 in Ukraine, caused by the coronavirus SARS-CoV-2, the Council of Doctors and Management of the Lviv Pulmonary Health Center, the leadership of Lviv Regional Hospital of Veterans of Wars, and represented after Yuri Lipa. We made some seminars. All seminars, doctors positively assessed the possibility of the created tools and confirmed the need for their practical application. This conclusion, I select main ideas and main result of this project. Now, of course, thank you for attention. You can find this our application on this web page, Health Supervisor homepage. Everyone from you can download this application and install on your smartphone. I think it will be useful for all. From our point of view, this direction is very potential and will be more and more development in the future. Thank you for attention.
Thank you, Anatoly Alexeyevich. Dear colleagues, question, please.
May I ask a question?
Yes.
Yeah. So firstly, I would like to thank for your interesting presentation and really up-to-date research. And you named some well-known brands of companies that make up pulse oximeters. And my question is, what is the main advantage of your application over existing ones? Because
okay, thank you. As I said, there are no concurrents now that have the same function. All of these companies that I named have application that allows to transmit data, measured data from these measuring devices to the smartphone only, and you can see your own parameters in this smartphone. Our idea was make such way that your parameters will see your doctor or your relative or other people, and not only you. Our idea is to give possibility to control patient, to control you, for example, by professional, not by yourself, by professional, but and it's on our from our point of view, it's very important.
yeah, I see. Thank you for your answer.
Thank you.
Thank you. Some questions, please. No questions? Thank you, Anatoly Alexeyevich. And our second plenary presentation is a high-level view of cybersecurity by Professor George Markovsky, Missouri University of Science and Technology, USA. Dear George, welcome.
Well, welcome. Thank you very much for inviting me. I wish I could be there in person, and I've been to Ukraine many times, and it's always a great place to visit. So let me get going on my talk. As you can see, it's called a high-level perspective. So I want to begin by just getting a couple of slides. that with some statistics that I'm sure will not be a surprise to anybody in this audience. And you see slides like this every day, but I think it's important to put a context in there. So if you look at cybersecurity spending in the US, you can see it goes up year by year. It's quite substantial. In 2018, it was up to $66 billion. I'm not quite sure where it's going to go in 2021. And already in 2020, people were thinking worldwide spending was $123 billion, which is a lot of money. And yet in 2020, the cybercrime losses were nearly $1 trillion. And depending on which survey you read, there could be several $1 trillion. So we have this very interesting situation. The loss is 7.5 times what we spend on cybersecurity. But if you look at more sad facts that I say, 68% of business leaders feel their cybersecurity risks are increasing. 71% of breaches were financially motivated. 25% involved espionage. 52% of breaches featured hacking, a quarter malware, and a third involved phishing or social engineering. And the number of security breaches keeps growing. To me, one of the shocking facts was that it took 7 months on average, after a breach for the people to know that they were even breached. And the average life cycle of a breach was almost 11 months. So that means from the time the hackers entered a system until they were thrown out was almost a year. And the average cost of a data breach in the United States was almost $4 million. And things, big companies like Uber were hacked and had to pay $100,000 in ransom and information on 57 million riders.
George, please, George, please share your screen because we do not see your slides.
Oh my goodness.
Okay.
Yes, that was a big oversight on my part. Sorry. Okay, you see it now?
Yes, thank you.
Okay, so let me go back a little bit. I apologize. So here were my slides on cybersecurity spending, and these are the losses, and then these are the facts that I just went through. But the important fact is that it takes 7 months for most organizations to realize they've been breached, and almost a year before they're able to get rid of the intruder. So what's going on here? We spend ever more money on cybersecurity, and our losses continue to mount and grow annually, and there does not seem to be an end in sight. So there's a lot of work going on, but the situation is not improving. So what can we do? Well, one of the things I think we need to do is we need to return to some first principles. And to solve a problem, you really need to understand what your problem is. And the issue is that we're really engaged in a multi-level cyber struggle. Okay, now I might almost call this a cyber war, but it's not entirely a war, and I'll explain why in a minute. And we need to understand that this is a very complex picture, and it involves a multi-level cyber struggle. And so the question that I want to address is, how do we go about constructing strategies to help us contain this cybersecurity crisis that we feel? So when I say call it a multi-level cyber struggle, what happens is there's this continuum of threats, of cyber threats that kind of run into each other. In other words, At the bottom level, you have individual hackers, people who are sort of fooling around with systems and things, and you have small criminals. It goes up to terrorists, uses, cyber espionage, could be commercial, whatever, organized crime, and then you start getting to activity that's caused by nation states. Now, the reason that I call it multi-level is that the kinds of attacks and stuff often appeared at different levels. And in particular, nation states, the levels are not independent. So nation states will disguise some of their actions by, just pretending that these are just independent activities of citizens or rogue groups or whatever, but they're actually part of a larger attack. Now, I call this a cyber struggle because if you talk about the term war, which is somewhat appropriate here, war is the continuation of politics by other means. And usually to have a war, you really need to have political entities involved. So if you have China and the US and they're each trying to gain cyber advantage over each other, that could be a cyber war. But if you have some criminal who's trying to steal Bitcoins from somebody else, it's not really appropriate to call it a war. And so some key points, you have to have political entities to have a war, and there is a cyber war going on. There are multiple cyber wars going on, but there's also a lot of other activity that shades into war. And sometimes people use the phrase war on drugs or war on poverty, but these are not really wars because you tend not to have political entities on both sides. I mean, there is no country of poverty that's fighting. So it's not always easy to distinguish among these categories, and nation states can hide behind a higher or organized cyber vandals and cyber criminals. There are all sorts of parties that are supposedly acting independently, but which I think are probably agents of certain nation states. And the idea is that in that case, it does become part of a war. It's attempting to exhaust your enemy. Now, if you go back to war, there's a famous classic by a Chinese scholar or philosopher called Sun Tzu, The Art of War. And it says that if you know your enemies and know yourself, you will not be put at risk, even if you have 100 battles. If you only know yourself, but not your opponent, you may win or you may lose. And if you know neither yourself nor your enemy, you will always endanger yourself. Well, I think in lots of organizations, if you want to say which of these three categories are they in, do they know their enemies and themselves? Do they know just themselves but not their enemies? And do they not know themselves and not know their enemies? I think a lot of organizations belong in the third category. They don't really have a coherent strategy, and they don't really have a good idea of who's attacking them. So cybersecurity is a constant struggle. Many years ago, 13 years ago, Linda Markovsky and I distributed a questionnaire to lots of supercomputer centers. And two of the questions were very interesting. And question 7, has anyone ever tried a physical approach to either disrupt a computation or steal data? So we wanted to know how many cybersecurity centers actually had somebody trying to physically impact their operation or steal data. And as you can see, there were almost 10% who said yes, 4% didn't answer the question, and 5% couldn't tell. Okay, this is very interesting that 5% of the installations didn't know whether it had happened or not. That means they were suspicious, but they did not know themselves well enough to know that whether or not they've been compromised. Then you notice over here, the second question is, anybody tried to bribe or influence one of your staff to help compromise the security? Again, you can see it's 8% here said yes, but there were 13% who were not sure, which means they suspected something, but really didn't know. And one of the things that, of course, makes cyber security difficult is that attackers can infiltrate an organization so that the attacks seem to be coming from inside. Anyway, here are just some of the common causes of data breaches, and you can see there's social engineering and in particular insider threats. I mean, you really do have people who kind of desire evil for an organization. And I think in a lot of organizations, they don't do enough thinking about insider threats. Now, when you talk about security, the first thing people think about is a wall. And if you want to look at history, you can say, how well have walls worked? And so here's a famous example. This is probably, you recognize the Great Wall of China, which looks like a tremendous barrier. It was erected, almost 2,000 years ago. But if you look at a wall, at this physical wall, it illustrates some of the weaknesses of walls in general. In particular, it's huge and you have to defend it. And you notice that here, for example, what they did was they would have these guard stations in various places so that ideally, if you try to attack the wall, the guards can get there. But of course, walls like this turn out to be not such great obstacles because people will pretend to attack at one place. And then when the troops all run to that place, they'll attack at a different place. Or they will dig a mine under the wall, make the wall collapse, and then run through. Now, what happens is the instant you penetrate this wall, its usefulness goes to zero, because as soon as you have one break, the whole thing just crumbles. And so walls have had a kind of notorious history of failing and not really defending people. So a while back, Linda Markowski and I also wrote a paper on the cyber castle. And people talk about castles, and so here was a picture of a castle, and you notice that this is not a very good defensive structure. For one thing, these poor people inside the castle can't attack anybody. They're actually, it looks more like a prison, and it suffers the same deficiency as a wall, which is if you get through it at some point, your defenses collapse. So one of the things that we did is we went back and we looked a little bit at the history of castles and how they were built. And one of the things that you notice that even though this was way before computers, people put a lot more thought into their castles than I think a lot of organizations put into their cybersecurity plan. So for example, they would start off by locating a castle in a place where it was easier to defend. Okay, so there'd be a river, they would have various gates, they would have all kinds of moats and things like that that would protect it. Even the structure of the castle itself, they would have towers. The towers would have separate stores and backup, and they could operate in various levels. So if you breach one level of security, there'd be another level to meet you. So the whole point that the castle makers thought about was how to make attacking the castle very difficult and time consuming, and so that they would make their castle stronger than other people's castles. So if somebody wanted to attack, they would go attack somebody else. Well, that principle is still good. So here's a sketch of two walls, and you notice the outer wall is actually lower than the inner wall, so that if people break through the outer wall, they have an even worse wall here. The other thing that is a little bit interesting is that if you look at how the walls were designed, they weren't just vertical, they had sort of angles to them so that if you threw projectiles, it would deflect things. I mean, in some sense, some of these ideas survive in modern tanks where you build armor and you don't build it just vertical, you slant it so that it gives you more protection against projectiles. The other thing which is interesting is that this was a toilet built on the outer wall so that they would make it difficult for the opponent to attack the castle. So they had defenses of all sorts. So you can see the entrance had various gates you could drop. If once an attack was underway, they would have planks that they would remove so that if people could break through, they would be stymied in running from one location to another. So they would remove this board so you couldn't just run from one part of the wall to the other. And in fact, when we studied things, this is a list of the kinds of defensive mechanisms that you would see in a castle, okay? And most people wouldn't even recognize that, but this is in medieval times when they built the defense, they would think about all of these pieces and this would be part of a coherent defense. So a lot of these principles can be applied for designing cyber defenses, okay? And they would also fool people. They would force people to go into particular things. Now, I don't have time to get into all these details, but there are a lot of tools that people can use in their cyber defenses, and very rarely does everybody use all of them. But and in particular, everybody wants to like think, well, we just did security and that's it, it's taken care of. But it's never taken care of, and you have to constantly improve it. So one of the things that you can do is you can look at these various things. So security is a process. You can't just be secure. You have to work at it constantly. Okay. So there's an interesting thing, an interesting exercise that comes from Bruce Schneier, who has an interesting paper on attack trees. And basically he says, assume that any security system can be broken, and work constantly to figure out how it can be broken and how you can make attacks as difficult and as expensive as possible. So you have to understand your own system. What's in it? What really needs to be protected? How can you layer structures? Like a lot of cybersecurity systems look like a wall. Once you get inside, you have access to everything. You have access to records, to library, to patents, to discoveries, or whatever. We need to think more about adapting the ideas of the castle makers to partition information so that every attack is met with some kind of defense. So in the attack trees, you can have two kinds of nodes, which are OR nodes and AND nodes. And an OR node is a goal that can be achieved if any of its sub-goals can be achieved. And an AND node is a goal that can be achieved only if all of its sub-goals can be achieved. So again, since this is a quick survey paper, I'm not going to get into a lot of details, but you can read the paper and find out. So here is an attack tree for trying to open a safe. And there are a variety of choices that people have come up with. Now, usually, one of the things that happens is that when people plan a cyber defense, they don't always take advantage of all the people that they have. And so to construct effective attack trees, you really need to reach out as far as you can to think of possible attacks. So here, for example, you notice that there are different attacks and various costs for them. So in particular, one is bribery. Okay, a lot of people think that if you have some kind of system that everybody is just 100% reliable and dependable. But if you look at, say, large companies, oftentimes security people are not well paid. And so if you can bribe them, you can make a lot of progress and, you know, for small amounts of money. So again, relatively small amounts of money. I mean, if you're going to get $1 million ransomware and you have to bribe somebody $20,000, then maybe that's a good trade-off. But the idea here is ultimately it'll cost you 10K to open a safe, because this direct attack here of cutting it open will cost you 10K, and all these other options will cost you more. Okay, so you can then focus, and notice this is just one question, like, what can I do for under $100,000? Here, for example, is what attacks will work if I don't have special equipment, and how much will they cost? So doing attack trees is a good exercise, and it should be done regularly. And in most organizations, there really isn't regular security practice, regular security updates, and it's really isolated. Now, another topic that I want to discuss is hijacking a domain, interceptor top-level domains. This is an attack that you can do against an organization. And the beauty of this attack is the organization doesn't even know that it's been attacked. So how does this work? Well, as you know, email, web traffic, key forms of communications for most organizations. And if you're going to steal information, think big. So this is an approach where you're just going to steal lots and lots of information, and by hijacking an entire domain. And if you do it, the victim doesn't even know they've been hijacked, and you can set up man-in-the-middle attacks. So what am I talking about? Well, I coined this concept of an interceptor top-level domains. So everybody's pretty familiar. There's, you know, .com, .net, .org, .ua, you know, for Ukraine and stuff like that. So, but it turns out there are lots of top-level domains that are similar to each other. What do I mean by that? Well, originally, in the early days of the internet, you had .com, .net, .org, and you know, and then people started creating new top-level domains. So in 2014, there were 639 top-level domains, and you can see how it grew over the years, and it seemed to grow very readily. Now, lately, it's actually begun to shrink a little bit. I just did a run yesterday, and there were 1,503 top-level domains. Most people don't seem to be aware that these domains exist, but I'll give you some examples from the top-level domains in a little bit. But then there's a whole issue of cyber squatting. I mean, first of all, if companies don't watch certain domains, it's easy to get domains that look like them. For example, I personally own IBMUSA.com. Now, if I put a website, you know, at IBMUSA.com, it looks very much like it could be an IBM website, right? And there are huge numbers of domain names that have IBM in them. And I was estimating that if IBM wanted to protect 20 domains like IBM, IBM USA, and for all the 1,500 top-level domains, it would cost them over $10 million a year to protect all those domains. And so, I mean, that's not even feasible for large organizations. It's certainly not feasible for small organizations. So what can happen is if you're typing, you know, we have things like auto completion, you can have incomplete specifications, Sometimes things defer to .com. And even if you give somebody a URL over the phone and you say the name, they might misunderstand the domain name. So an interesting case happened between Goldman Sachs, where somebody wanted to send an email to someone at gs.com, but it ended up getting completed and went to gmail.com. Okay, not a big error, but it was a very confidential document that was emailed to the wrong person because of this auto-completion error. So errors like this can happen all the time. And it turns out that if you buy one of these domains, you can set up what's known as a catch-all email address. So it'll catch any email address to that domain. So I could set up ibmusa.com as a catch-all email address. And so if anybody sends anything to ibmusa.com, I will get it. Okay. And so who knows what I would get. So another example is there's a top-level domain called .career. There's also a top-level name called .careers, and the only difference is the S at the end. Okay, so if someone registered a business that said good.career, and they'd have Smith at good.career, I could register something called good.careers and set up Jones at good.careers as a catch-all email address. And so any email that a person typed careers instead of career would go to me and not go to the intended company, the intended address. And so anything sent to Smith at good.careers will automatically go to Jones. And anyway, this is a severe security problem, and it's part of rethinking your whole structure. So I generate this report that shows you which top-level domains are similar to other top-level domains, so that you don't have to register 1,500 different versions of your domain name, but you might want to register the ones that are close. So for example, .com is very close to .co. So you can spoof a company by registering .co, and if you have a .com, you might want to consider trying to get the .co. So I have a report that I'd be happy to share with anybody who's interested. A last topic that I want to cover is what I call the metric at the end of the rainbow. So you'll see statements like this: defining effective information security metrics has proven difficult, even though there is general agreement that such metrics could allow measurement of progress in security measures at a minimum rough comparisons of security between systems. So people want to have some kind of a metric where you measure all kinds of things about your system and whatever, and out comes a number, and that number tells you how secure you are. And then the idea is that you keep, fixing this and fixing that and keep increasing your number, and then that number really measures your security. Now, people say it's defining these measures has proven difficult, and the answer is, yeah, it has proven. Okay, and then it goes on and says general community agreement on meaningful metrics has been hard to achieve, and they attribute this in part to the rapid evolution of IT, as well as the shifting focus of adversarial action. And the real reason they're having problems is it's not possible to construct a reasonable metric. And the paper that I just cited that shows that if you really think about what requirements a metric would have, it's not possible to construct such a metric. And searching for such a metric is like searching for a pot of gold at the end of the rainbow. So something that, you know, I don't know if every language has this expression of searching for gold at the end of a rainbow, but that's it. And so there's just no good way to take different, what I call apples and oranges, and come up with a scale that accurately reflects them. That ultimately you have to decide what factor is going to guide your security system. And a lot of this is you have to understand your enemy. You have to understand their strategies and how they're likely to infiltrate your organization. So it really comes back to some of the things that Lao Tse said several thousand years ago. And here's my illustration of the security metric at the end of the rainbow. And so to all of that, there's one other topic that I just want to very briefly mention, and that is quantum computing and how quantum computing will affect security and all that going forward is another thing to worry about. So that's my talk.
Thank you, Professor Markowski. Questions, please?
Excuse me, may I ask a question?
Yes, of course.
Thank you, and thank you very much for your great presentation. I would just like to ask a sort of a general question. What is, in your opinion, the weakest sort of link in a commercial company? Its staff that can be corrupted, or some technology that has a technological blink, some bad guys can go into it. So it's the human factor or technological one? I mean,
well,
now.
You see, that's what I think is the danger, is trying to give one answer that works for all companies. Okay. In other words, that's why what I'm saying is you have to be like a castle creator. You have to sit down, you have to look at your security posture, you have to understand what your vulnerabilities are. Several years ago, I talked to a security director at one of the national laboratories we have at the US, and he said his main concern was building firewalls against his own people. Because he said, you know, we have these people who are PhDs, but somebody mails them a link and they click on it. And the instant they click on it, all the malware comes inside the organization, and now he's being attacked by the accounts of his own people. And the people are not necessarily evil, they're not necessarily bribed, but they're just careless. And so sometimes, you know, you don't know whether they're dishonest or careless or whatever, but a lot of organizations don't really think through a strategy, you know. And again, like you say, it could also be equipment. I mean, if you're using old things, I mean, like you remember, you watch when they discover a flaw, okay, some kind of security weakness. And then you look at how long does it take an organization to apply the patches to known vulnerabilities? Well, the answer is sometimes it takes a year before they patch a system. Well, during that year, you're open. So the thing is, a lot of hackers now are in it for business reasons. So they will go whatever is easiest for them. Is it to send a phishing email? Is it to exploit known vulnerabilities? I mean, you have tremendous scanners like Shodan and what that will tell you what versions of software are being used where. And then you can go on the internet and look up exploits, okay? Mm-hmm. And a lot of organizations should do that to their own systems, you know, and they don't. Okay, that's what I'm saying is you need to kind of have a strategy. They just want to say, oh, we hired this guy, everything's okay because we're paying him lots of money. That's just not going to work.
Yeah, that's a good point with the business, because as soon as you realize why people hack some system, you can understand what weaknesses are and how to sort of avoid them, kind of, or make a castle, as you said. Yeah, thank you very much for your answer.
Oh, you're welcome.
Thank you, dear colleagues. More questions, please? No question?
I have some suggestion.
Yes, yes.
Hi, George. Hi.
Hey, Anatoly.
So I think a good presentation, very impressive. Thank you, George. So, and my suggestion is, please try to prepare a good survey for some Ukrainian journal in this area. I think it will be interesting for people, probably
Okay.
even for journal in Khmelnytsk National University. Thank
Okay,
you.
well, I'd be happy to work with people on doing a survey on, you know, Ukrainian cybersecurity practices. But I think we have to think a lot more strategically. You know, it's not just a matter of this device or that device or, you know, some setting on a firewall. We have to make security a more global kind of concern. And it has to be important to the whole organization. You know, when they built the castle, the people who would be inside the castle worried about, did we stock enough food? Do we have enough defense? I mean, it wasn't just like, oh yeah, those guys will take care of it. You know, they thought about it.
I have a question, George. As I am looking at your screen, I see quantum computing, and I have a question. What have human to do when we will use quantum computing, and it will be able to break all security channels and so on? And I suppose it will be a great problem for cybersecurity as well.
Yeah, actually in December, I'm on the program committee for a forensics conference that we're running in Singapore. And I'm hoping to have a session on quantum crime where, you know, I'm going to solicit papers so that people start thinking about this capability, because as quantum computing develops, I have no doubt that the criminals will make investments to take advantage of that technology. So if we don't start thinking about it, we're going to find ourselves really in very terrible shape.
I'd like to add that maybe the quantum computing maybe will be took into cybersecurity field as a tool to protect some systems, maybe.
Yeah, and I think we need to start thinking about, you know, like a lot of tools, you can use it both for good and for evil. And I think that we need to start thinking now.
Yes, you are.
Not after, you know, all the breaches and all the crypto has been broken or whatever. We need to start preparing now.
Yes, thank you.
You're welcome.
Thank you. No more questions? Thank you, Professor Markovsky.
Well,
And
thank you for inviting me.
Now we are collecting papers in the first issue of the new journal, Computer Systems and Information Technologies of Khmelnytsk National University for 2021. And taking this opportunity, I invite everyone to submit your papers in our journal, in our new journal. Now we have a coffee break. Each of us will make himself a delicious coffee or tea and drink, unfortunately alone at home or at work. Of course, we would all like to drink this coffee, coffee together, talk, discuss our interesting presentations, but unfortunately the coronavirus deprived us this opportunity, and so we have a coffee break alone and meet at 4 p.m. to continue our plenary session.
Okay. Good.
Dear colleagues, let's continue. Dear colleagues, let's continue. Our third plenary presentation is intelligent system for building separation on a semantically segmented map by Professor Volodymyr Gnatushenko, Dnipro University of Technology, Ukraine, Vadim Zhernovy, Oleg Gonchar, Dnipro National University, Ukraine, Dr. Irina Udovik, and Olga Shevtsova, Dnipro University of Technology, Ukraine. Professor Gnatushenko was supposed to make a presentation, but he is busy in the election of the rector and has connecting problems. So the presentation will be made by Vadim Zhernovy. Welcome, Vadim.
Hello, everyone. Can you hear me?
Yes, yes.
Thank you, Tatiana. Dear colleagues, I want to present you our research on a topic, intelligent system for building separation on a semantically segmented map. We will speak about a little bit of our motivation and state of the art in this direction, about our objectives we wanted to achieve with our work, approach and methods we implemented and suggesting you today. As well, we will cover some experiments and results we obtained during our development. So our motivation and challenges we wanted to work on in this research were a challenge of feature instruction in remote sensing. This challenge exists due to a complexity of remote sensing imagery data. Usually remote sensing data is very high resolution images which weigh multiple gigabytes, and they are often multispectral, which means there are not only red, green, blue channels like in regular images, but also other visible lengths of other colors, and as well near infrared and shortwave infrared bands, which creates the challenge of extracting as more information from these images as possible. As well, we wanted to apply novel technologies of artificial intelligence and deep learning in particular. Maybe our main motivation here was how to apply and how to represent the result of such processing with deep learning algorithms, because we often say that the semantically segmented map and other products of artificial intelligence could be applied to solve many problems in different areas of knowledge, but we wondered how exactly we could apply it and maybe automate it. So the challenge of feature instruction, we briefly said about feature extraction problem in remote sensing images. Feature extraction itself is creating some features to make some machine learning or deep learning algorithms work. When we work with remote sensing data, we have much more techniques. Some of them are on this slide. We apply some of them, such as image tiling technique, which takes place when you work with images of very high resolution, because our neural network we used in this research accepts images of smaller size, so use of image styling techniques were necessary. As well, we use some annotation techniques often known in work with RGB images even, and as well as we used different band combinations, which I briefly said about, like bands of other visible lens, wave lenses, and infrared bands. State of the art in deep learning for remote sensing are, in generally speaking, 4 types of neural networks. In this particular research is stopped on deconvolution networks due to their configurability, simplicity of use, and their efficiency in general. More in details on this next. And the main reason why we proceed with such research, we wanted to do something with results of deep learning algorithm. In our research, and as well as in many other research papers, a result of some map processing is semantically segmented map. It's image C on the slide with caption prediction. We see that blue stands for some buildings, car are yellow, etc. But we usually say that this map could be used by domain expert, in this particular case in remote sensing, somehow. And okay, we see some cars, buildings here, but we still need some knowledge about the source image, like its spatial characteristics, like what size of these cars, or maybe how many of them. We still need to count them, even semantically segmented map, which still complicates work with such maps for domain experts. So we wanted to implement something upon that to solve such complications and problems. So objective of our research was to investigate ways to apply deep learning segmentation results somehow, and suggest end-to-end AI technology for deep learning results post-processing. We wanted to make it simple and configurable. Like for any almost any deep learning algorithms, we needed a data set. In order to prepare a good data set for remote sensing tasks, we need to consider many different characteristics of remote sensing imagery, like it could be spectral, spatial, radiometric, and temporal. Temporal are not considered in this research simply due to we don't do some change detection or something related to time. But in order to design our data set, we relied heavily on spectral and spatial characteristics. So we used different band combinations, and also we need to know pixel resolution for our post-processing algorithms, which is applied on results of deep learning processing. And some tools we used are image annotation with ArcMap from ArcGIS package, VGG image annotator. It's an online tool and also available on GitHub. Some tiling techniques, image band combinations, and indices. Indices like vegetation index, road extraction index, and a few other custom indexes developed by other researchers. And some general image processing techniques like normalization for input data for deep learning algorithms, or histogram equalization, etc. Special characteristic of our imagery and data set we developed it from are on the table on the slide. let's proceed to the next part. UNET is deconvolution network, and it is often used in research for remote sensing. It is scalable, it is efficient, and what was very important for us, it is trainable on small data. I said that Voltage 3 imagery and even our image were of very high resolution, but when we tile it on smaller images, for deep learning, it is still considered as a small data. So we're still scarce in data for training a good deep learning algorithm. So UNET was a good choice for us. Some other UNET modifications are also mentioned on the slide. We use them for general comparison. So we know that our algorithm is not worse than existing implementations, and also complements our post-processing algorithm work. Our neural network backbone is also UNET-like. It consists of encoder and decoder block as original UNET network, and modified with additional extra convolution block and with output sigmod activation layer. It's not much different from original UNET, but we found this configuration complements our post-processing routine the most. So we stayed with such implementation. Evaluation metrics which we used for evaluating our deep learning algorithm, our neural network, is dice metric and dice loss, and we stayed as well with binary cross entropy loss function, which is used in the original research of UNET. So our resulting loss function is summation of both. Neural network training results are on the screen. Accuracy is pretty high, but it's not really representative. And if we check other UNET implementations, even on different data, accuracy will also be high. So UNET is also widely known for its high accuracy. So 98% is not something impossible for UNET. But so we also calculated some other metrics like precision recall and F1 score, which somehow represents both impact of precision and recall to estimate general performance. And additional implementation on the top of our UNET-like neural network was implemented for instance separation. And it is used to solve one particular task, is to split different masks on an image. This is because output of UNET is the image of is a bitmask actually of the same size as input image. This is exactly how the convolution networks will work. So your input is an image of certain size, and output is also the image of the same size. And since we wanted to run our post-processing routine for each separated land object on our image, in our case it was buildings, we implemented a routine to split masks for each particular building on whole skin. We applied also thresholding algorithm to evaluate a proper threshold to split these instances. It also was required because UNET estimate belonging of each pixel to the class of buildings. So it's not zeros or one, it's rather a float number from 0 to 1. So this also thresholding were necessary. Another additional improvement were done here to eliminate false positive results, which are small masks. We eliminated them by pixel count. Maybe that's it on this part. And the part related to our post-processing routine, we wanted to do something with semantically segmented maps. We implemented a simple proof of concept of such post-processing algorithm. We estimated and approximated the perimeters and square areas for each separated masks on the skin, and implemented some custom indices. In our case, we decided to go with build density, which is proportion of properly detected pixels according to our post-processing routine to a total amount of pixels on the screen. And we also run more experiments with our implementation. Since it's complex, we compare different parts of it. So as I previously mentioned briefly, we compared our architecture with some other .NET implementations. The accuracy is pretty high for our architecture on our data, but accuracy is not really precise characteristics when we're talking about .NET. And as another reason for such high accuracy was that it was tested and trained not on the same data, but the data from the same area covered with satellite. So it might be the reason. Regarding precision recall and F1 score, .NET is still better, but it didn't complement our post-processing routine, so we stayed with our implementation. And some example of our built-in calculation results for the previous image on the previous slide are on the second table. So we calculated maximum horizontal and maximum vertical diameters with minimum fitting rectangle box. We calculated with this diameters, perimeters, and areas, and we also calculated some more complex characteristics like build density for the image I showed you on the previous slide. It was 23%. When we analyze the whole skin, this density parameter is actually a bit lower by from 5 to 10%. So some conclusions we made from this research, and also we defined some future research directions. The approach for end-to-end pipeline includes pre-processing, neural network, and post-processing routines. Pre-processing stage heavily relies on the results of our previous work. We said that we apply a lot of different techniques like image styling, band combination, but it's not covered in current work, and it is relied on our previous research, which we refer to in our current one. The neural network part of the solution keeps the novelty of .NET and AI in general for remote sensing, so it's a good direction of any other research for remote sensing, and we suggesting another approach to configure this .NET architecture. The post-processing routine solves very applied tasks fully automated, so you don't need to do something additionally with semantically segmented map. So output of our suggested implementation is semantically segmented map and the calculation. So when you start working with semantically segmented maps, you also have some numbers and some characteristics of objects on this map, which accelerate work with such maps. All suggested mechanisms are flexible and interchangeable, so you may approach the same workflow with different data set or different neural network and find some other maybe better results. I wanted to show you a small bonus. It's not covered in our research paper we submitted to this conference, but it's our current work. It's in the development. We are going to present it later, but we are trying to apply the same approach, the same workflow for different data. On the screen, you may see ultrasound images, which is not that complex as remote sensing imagery data, but another challenges are here, like low saturation of the image, low contrast, and we also apply here our post-processing algorithm, like calculation of maximum vertical and horizontal diameters, and some other characteristics are used for physicians. Maybe you notice on the result of ultrasound diagnosis, some sizes of some organs which operators do manually. With our approach, it might be possible to do automatically, which saves time and maybe make your results more accurate. Thank you for your attention. Questions are welcome.
Thank you, Vadim. Questions,
Thank you.
dear colleagues? Questions, please. No questions?
Can I ask a question?
Sure.
Have you used the image filter for image preprocessing?
Yeah, we definitely used some filtering on our source images. First thing to know about our imagery, it is originally our area of images. Is the largest one is pan-sharpened panchromatic image, which is of high resolution, but is monochromous, and we have smaller images which are hyperspectral, but with lower spatial resolution. So we applied fusion techniques called pan-sharpening on these images to obtain a single image of very high resolution and to keep hyperspectrality. As well, we applied also shadow removal algorithms, which makes our deep learning results are much better for in terms of instance detection, because shadows in our case make our deep learning algorithm work much worse. And for post-processing routine, we applied also thresholding to distinguish different masks for different buildings. Maybe that's it.
Yes, thank you.
Thank you.
Hello, Vadim. Thank you for
Hello.
your presentation. I'm Yüksel. Sorry, I have no camera. Did you try your data set on the popular CNN methods, such as AlexNet, GoogleNet, ResNet, like that?
No, we decided not to go with this with these implementations. We originally worked with region-based CNN, which is Maskar CNN, but the results on that were a little bit worse than UNet, and to be honest, the processing speed is very slow because our single image weigh 4 gigabytes, and processing even of one skin took hours for us. So we proceed with the convolution architecture. So no, in this work we didn't even consider using AlexNet or similar networks.
Okay, thank you. When I seen your results, you have some error at the shadows. You can, it's just suggestion for you, it's not like question. You can use some deep learning method that you can fix, you can complete your shadows, you can complete your images before apply on your deep learning method. It is just suggestion for you. You can try like this. You can get more and accuracy, maybe. I don't know, but your accuracy is very good. It's not. It's very good. Your accuracy is 98%. Is very nice.
Yeah, thank you for your suggestion. It's really might be a good improvement to applying technique you suggest. It is just not covered in this work, but we should definitely consider it, try and maybe publish in some other work. Yeah, thank you.
Okay, thank you, Walid.
Thank you.
One more question from me, please.
Yes, of course.
Thank you very much for your presentation. I would like to ask, how did you choose the structure of the UNet architecture? Did you use any additional experiments that you structured in this way? I mean, encoder block with 5, if I'm not mistaken, 5 encoder blocks, 5 decoder blocks, several convolutional blocks. I mean, did you follow any guidelines, some pieces of advice, or you conducted several experiments to finish exactly this kind of structure? Could you please share it with us?
Yeah, regarding encoder and decoder blocks, they are standard even in original UNet architecture in the original paper. The one modifications done here is actually additional extra convolution block and modified evaluation matrix. But yes, we approached this problem. We wanted to find a way to configure our network to complement our post-processing routine. How did we proceed with this? We started with the original UNet. There are many even implementations available on GitHub with different frameworks, and we started with small data sets and the original UNet. When we obtained some results, we increased the size of our data set twofold and tried to overfit the model. When we overfit the model, we increased the size of our neural network, and for our data set, adding one extra convolution block were enough. So if you ask for some guidelines, we suggest to go with something original, which you may start with, and just feed it with a small data set and then more data until it overfits. And when you overfit the model, then you could increase it in size. In UNet, it could be done by adding extra convolution blocks. Maybe that's the answer.
Yeah, all right, thanks. And the last question, how much time did it take for you to train the model based on this network?
We used online available tool named Google Collaboratory, and for our UNet implementation and our dataset size, it took 1 hour for 100 iterations, 100 epochs with our dataset. It depends on the size of your data, but if you work with small data, you might obtain some results with UNet in a few hours using Google Collaboratory environment, which includes one GPU available for you.
Got it. Thank you very much for your answers.
Thank you, Tim.
Thank you, dear Vadim. Our fourth plenary presentation is Intelligent Information Technology for Providing Human Resources to Projects in a Multi-Project Environment by Dr. Natalia Dotsenko, back at the National University of Urban Economy in Kharkiv. Dr. Dmytro Chomachenko, National Aerospace University, Kharkiv Aviation Institute, Dr. Yulia Guseva, Dr. Irina Kadekova, and Professor Igor Chomachenko, faculty of National University of Urban Economy in Kharkiv, Ukraine. Who is speaker? Dmytro, yes?
Yes, hello, and can I ask Vadim to stop sharing his screen because I cannot share mine.
Okay.
So I think now you can see my screen, yes?
Yes, yes. Okay.
Okay, so thank you for the opportunity. I will present our research, intelligent information technology for providing human resources to projects in a multi-project environment. It was made in Department of Project Management and Urban Economy of Beketov National University of Urban Economy in Kharkiv, with participation of National Aerospace University Kharkiv Aviation Institute. So developing sustainable human capabilities for project team members during the COVID-19 crisis increases team resilience and facilitates the adaptation of technical skills to dynamic economic changes. In a crisis, the company's management faces the task of improving human resource management in order to optimize them. In some cases, it's impossible to do it without staff cuts. Reduction of personnel, aggressive influence of the external environment, increased mobility of team members lead to an increase in project risks associated with the influence of the human factor. To increase the viability of projects and the company's competitiveness, it's necessary to apply modern approaches to human resource management in project-oriented companies. The development of effective methods for managing human resources of a multi-project is an urgent task, since for the implementation of a multi-project, it's necessary to synthesize the resources of individual projects within the existing constraints. Multi-project management leads to the need to analyze the distribution of resource between portfolio projects. By multi-project management, we mean the management of a group of projects, programs, or project portfolios carried out by one or more organization in the industry in a certain period of time to achieve the strategic goals of the industry or a certain cycle of stakeholders. Product development organizations are faced with a growing number of fast and small development projects to meet market and customer needs. The characteristic features of human resource management in a multi-project environment are the presence of a certain cycle of stakeholders, the need to ensure the management of critical competencies, specific requirements for the resource management, and involvement of performance in several projects. In order to ensure rapid product development, it's proposed to allocate competent developers for quick projects, joint placement of a development team, effective personal communication, and the implementation of a specific but flexible process for rapid product development. Some researchers consider the formation of the project team taking into account the possibility of collaboration, the level of expectation of the participants from the project. Application of a multi-agent approach to the allocation of human resources is aimed at solving problems when planning several projects with limited resources in conditions of uncertainty. When solving the decentralized problem of finding a compromise between time and costs in multi-project, time-cost trade-off problem, project planning and resource allocation are performed in a distributed manner by autonomous project managers to optimize local goals and taking into account global requirements. When planning a project in multi-project environment, there are resource-constrained project scheduling problem, resource-constrained project scheduling problem with bounded multitasking, multi-mode resource-constrained project scheduling, robust resource constraint multi-project scheduling problem, project scheduling with dynamic resource allocation in a multi-project environment, and the task of planning a portfolio of projects in the context of restrictions on the available labor resources of various specializations and fuzzy estimates of labor costs for performing works. The use of multi-criteria optimization based on the modified TOPSIS method in solving the human resource management problem allows ranking alternative solutions for human resource management, further analysis and selection of the final solution. Targeted search is used to provide the company with employees with critical competence. Its effectiveness is determined by the formalization of requirements for the candidate, determined by the requirements for the project and the interests of stakeholders. So when managing a project portfolio, the stakeholders are the supreme governing body of the company, which makes strategic decisions on the development of the company portfolio. Portfolio management group, portfolio director, portfolio management committee, or portfolio board, managers or leaders of programs, managers or leaders of projects, program or project office, teams of programs or project clients, and suppliers and partners. The methods of attracting employees to the project team are determined by the availability of resources in the company, their availability at a certain point in time, and the consent to take part in the project. As a result of the analysis, it was determined that in most cases, approaches to human resource management in a multi-project environment are based on automated centralized decision-making. The use of Agile Scrum, Scrum's flexible methodologies will ensure decentralization and self-regulation, which is especially important when managing projects in IT companies. The use of flexible project management methodologies has led to the need to solve a number of tasks caused by self-organizations of teams. Changing resource requirements, engaging senior management in project level sponsorship, achieving cross-functionality and effective team level evaluation, the statement of independence and independent assignment of resources at the individual level, and lack of eligibility criteria and dependencies at the task level. Resource management in a multi-project environment includes planning, distributing, balancing, and coordinating resources in individual projects, as well as resolving resource conflicts between different projects in order to achieve an optimal allocation of resources between projects in a multi-project environment. A model of interaction between the processes of stakeholder management and project resource management consists of stakeholders identification, stakeholders engagement, planning, stakeholders engagement management, stakeholder engagement monitoring on one side, and resource management planning, operational resource estimation, resources acquisition, development of project teams, team management and resource control on the other side. In order to increase the efficiency of project management, it's proposed to consider the integration of stakeholder management and project human resource management. The relationship between human resource management process in a multi-project environment and critical competence management processes. The methods of project-oriented management of the provision of human resources for projects in a multi-project environment is proposed. Based on the analysis of stakeholders' interest in human resource management processes, taking into account the loyalty of stakeholders, which unlike the existing ones, takes into account the consistency of certain resource constraints, which will provide project teams with the necessary resources for given restrictions. Among the main tasks that arise during changes in multi-project environments, the most urgent is redistribution of resources between projects, while ensuring existing restrictions. The current direction is the criterion of an adaptive team, a team that reacts to changes in the currently available business requirements and technical requirements for the project and its product by redistributing functions with the same team composition. They need to take into account changes to the requirements of the projects and the project product to adapt the team to the change requirements, the ability to resolve and ensure a donor-acceptor interaction leads to the need to develop methods for redistribution resources in a multi-project environment. Implementation of projects in a multi-project environment with a limited pool of resources, staff reduction during a crisis leads to involvement of performers in several projects at the same time. On the one hand, this approach reduces the amount of resources involved, but it can also lead to decrease in the efficiency of project implementation due to the switching of performance attention between projects and the need to focus on the completed projects. At the stage of resource planning in a multi-project environment, it's proposed to determine the maximum possible degree of involvement of an employee with a certain qualification at which he can perform work with a given quality. The degree of overlap of projects by the parameter human resources shows the number of performers simultaneously involved in the implementation of a given combination of projects. Excessive involvement of employees, especially middle management in various projects, leads to a decrease in the efficiency of functioning and increase in the influence of the subjective factor and a decrease in the quality of decision made. The maximum possible degree of involvement of the performer in the project is the number of projects carried out by this employee in a certain period of time with the given quality indicators. The maximum allowable load for the whole organization reflects the percentage of resource utilization. For example, in budgetary institutions, the maximum allowable workload is 150%. It's one rate of full-time employee and half of a part-time rate. Using overlapping positions and allowance can increase the maximum allowable workload. The maximum load on the certain project at a certain time interval is determined by the amount of involvement of the certain performer in certain projects, hours or percentage rate. For the purpose of analyzing the involvement of human resources in the project portfolio, methodological support has been developed. So a method for analyzing the involvement of human resources in a portfolio of projects consists of stages you can see on the slide. Stage 1 is formation of maximum permissible engagement metrics for each job position. So is determining the maximum possibility degree of involvement in the project, determination of the maximum allowable load in the whole organization, and determination of the maximum load in one project at a certain time interval. Stage 2 is determination of prohibited combinations of involved performers. At that stage, a check is performed, so prohibited combinations of roles by one performer with the IS project, prohibited combination of work performance by one performer in different projects of the project portfolio, overlapping prohibited by the conflicts of interests of stakeholders, its analysis of resource requirements of stakeholders, and stakeholder loyalty analysis. After analysis for consistency, a set of prohibited alignments is generated, which displays all prohibited alignments in the project portfolio. And stage 3 is building a positional diagram for a portfolio of a project. The next stage is analysis of the involvement of human resources in portfolio projects using positional diagrams. Consist of audit of portfolio of projects by the criterion of prohibited combinations, audit of the project portfolio by the criterion of engagement metric, audit of project by the criterion of prohibited combinations, and audit of projects by the criterion of engagement metrics. Stage 5 is determination of constancy, and stage 6 is development and implementation of corrective measures. To formalize resource management in the project, a model of the process of analyzing the involvement of human resources in the project portfolio is proposed. Its engagement metrics can be involvement of stakeholders in the project portfolio, which characterizes the number of projects in which stakeholders is involved. Involvement of stakeholders in the projects, which characterizes the level of involvement of stakeholders in the project. Interest of stakeholders in the project management, interest of stakeholders in human resource management of the project, and stakeholder loyalty indicators. So on the next slide, you can see a model of the process of analyzing the involvement of human resource in project portfolio. So here we have processes. F1 is formation of engagement metrics. F2 is determination of prohibited combinations of involved performers. F3 is construction of positional diagrams for a project portfolio. F4 is analysis of human resource involvement. F5 is determination of consistency. F6 is development and implementation of corrective actions. Also, we have inputs. So I1 is a group of inputs displaying information about the current project. I2 is resource requirements of stakeholders. I3 is job descriptions. I3 is corporate standards. I4 is HR standard service. I5 methods for constructing positional diagrams. 6 is job descriptions. I7 analysis methods, and I8 is stakeholders. And outputs, boundary permissible engagement metrics, prohibited alignments, positional diagrams of a project portfolio, analysis results, verification results, corrective actions, and report. The use of logical combinatorial approach will allow analyzing the distribution of human resources between projects in a project portfolio. The use of positional diagrams visualize the analysis of the degree of involvement of performers in the project. If the executor is involved in the execution of the project, here is displayed in the corresponding elements of the positional diagram. In the absence of the possibility of attracting resources from the pool to the project that are not involved in the implementation of other projects when reallocating resources in a multi-project environment, it's necessary to take into account the interests of stakeholders and their loyalty. In order to reduce the risk of conflict situations, redistribution in projects is carried out among projects in which a minimum number of stakeholders are involved. So I showed some notations in the next slide, and on slide 14, you can see the diagram of overlapping projects by the parameters of performers and stakeholders. The distribution of human resource management processes is time depends on the stage of project implementation. Since the resources in the project are involved in a certain time interval, then after the work is completed, the resources are released, which can be later be used in other projects. So donor-acceptor resource interaction in a multi-project environment is due to the presence of the single pool of organizational resources, within which resources are redistributed between the work of donor projects and acceptor projects. If it's necessary to attract additional resources to the project, an assessment is made of the possibility of redistributing resources. So it's availability of resources, their cost, and duration of redistribution. So on the next slide, you can see methods for analysis of stakeholder-oriented resource reallocation. It consists of 8 stages. Application of the developed methods makes it possible to take into account the level of loyalty of the stakeholders of human resource management process when reallocating resources in a multi-project environment. So let's consider the application of the proposed method. Let the stakeholder who are involved in the project management be defined as it shown on the slide, and the project implemented by stakeholders, which is shown in stakeholder project matrix. You can see it on the slide also. ST equivalence of projects. Projects have the same combination of stakeholders involved. In the consider example of a portfolio of projects, ST equivalent projects P2 and P6, and the matrix of overlapping projects by the parameters of projects and stakeholders is shown on the slide. So we defined a set of project teams implemented in a multi-project environment, and you can see a matrix of performers who can participate in the redistribution. So 1 is if he can, 0 if it's impossible. Based on the analysis of the project teams implemented in a multi-project environment, we determine the indicators of the involvement of parameters in the projects of stakeholders. A quantitative indicator of the involvement of performers in the projects of the stakeholders is shown on slide 19. And the next slide shows the involvement of performers in stakeholder projects. So table shows that Q3 participates only in the projects of the third stakeholder, which will ensure the transfer between projects without additional approval. For the given example, a diagram of the overlap of projects by the parameters of performers stakeholders is built. For the considered case, when several stakeholders are involved in the implementation of the project, we adjust the positional diagram, exclude the corresponding combinations of stakeholders from consideration to take into account the interest of stakeholders and identify a potential conflict of the redistribution of project portfolio resources. It's proposed to use the loyalty matrix, which reflects the relationship between stakeholders. So it's shown in the next slide. And the loyalty matrix element reflects the assessment by ICE stakeholder of the attitude towards the YOT stakeholder. And the score is measured in points from 3 for complete trust to -3 for extreme degree of dislike. Based on the analysis of the stakeholder loyalty matrix in the positional diagram, we determine the projects during the implementation of which there may be a risk of project's failure due to a conflict of interest of stakeholders. It was determined that the portfolio involved the first and 6 stakeholders who have an extreme degree of dislike, -3, according to our loyalty matrix. Then, when analyzing the diagrams, we identify problem cells. So a figure on the slide shows a diagram of overlapping projects by parameters, performers, stakeholders, and the number of performers are indicated. So the analysis of the positional diagram reveals a conflict over the involvement of performers in project when redistributing resources corresponding to the configuration of the positional diagram cells CT1 equals to 1 and CT6 equals to 1. It's necessary to take into account the interest of stakeholders in a specific resource and to carry out the redistribution only upon agreement with the stakeholders. If other stakeholders are involved in the redistribution, it's possible to smooth out the conflict since they having a positive level of loyalty towards ST1 and ST6 can positively influence the position of the first and sixth stakeholder. Performer of works at ST1 and ST6 equals to 1 is shown on the slide. The most critical is a redistribution of resources for the first configuration. Executors, performers who are shown on a table, since the configuration of stakeholders doesn't include the involvement of other stakeholders. For the second and fourth stakeholders conflict don't arise since there is no overlap of projects in which these stakeholders are involved. So it's advisable to redistribute resources into the project, taking into account the results of analysis of the involvement of human resources in the project portfolio. So based on the given models and methods, a software package for project-oriented resource management in multi-project environment has been developed. You can see it on the slide. It consists of 20 programs, which all has certification in Ukraine. So the problems of planning a project with limited resources and planning a project with limited multitasking are urgent problems that require the development of modern methods and approaches. At the same time, the dynamic change in the customer requirements, the impact of the project environment, aggressive competition for key resources, impact of social trends, and the consequences of the COVID-19 pandemic lead to the need to constantly monitor the allocation of resources in a multi-project environment and ensure a flexible reallocation of resources between projects throughout the entire life cycle portfolio of projects. Methods for analyzing the attraction of human resources to a project portfolio are proposed based on the use of logical combinatorial and stakeholder-oriented approaches in managing teams of a multi-project organization, which is contrast to the existing ones, carries out resource analysis of projects, which makes it possible to increase the efficiency of using human resources in the project portfolio. A promising direction is software for automating the analysis of the provision of human resources to projects in a multi-project environment. Thank you for your attention.
Thank you, dear Dmitro. Questions, please, dear colleagues?
I've got a question.
Yes, of course.
Please, you have represented your model with IDF notation. Could you specify input and output data in your model?
Just a second, I will open it. This one, you mean? Yes?
Yeah. I mean, maybe I1 and 07.
Yes, so inputs are it's a group of inputs displaying information about projects, resource requirements of stakeholders, corporate standards, HR service, methods for constructing positional diagrams, job descriptions, analysis method, and stakeholders. And outputs are boundary permissible engagement metrics, prohibited alignments, positional diagram of a project portfolio, analysis results, verification results, corrective actions, and report. So outputs are all from 1 to 7.
Yeah, I see. Thank you. It was really interesting. Thank you.
Thank you.
Thank you. More questions, please? No questions? Okay, thank you, Dmitro.
Thank you. Hope to see you next year in Khmelnytsky.
Okay. Now our plenary session is over. Tomorrow we start at 9 a.m. from section session first, Intelligent Information Technologies. Section session second starts tomorrow at 11:30 a.m. We invite all guests and participants of the workshop to take part in the discussion at tomorrow's section sessions. Have a nice evening, everyone. Goodbye. See you tomorrow.
Bye-bye.
Bye-bye.
Bye. 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 Have a nice evening, everyone.
Bye.
Thank you very much. Thank you.
Thank you very much.
Thank you.